Hi everyone, welcome back. In this week's videos, we're going to continue our exploration of p5play through examples. We're going to build a small spaceship game where we're going to use that as an excuse to elaborate a little bit more on the physics, kind of working on more advanced controls for our player character. We're also going to talk a bit more about advanced collisions, so having our ship being able to shoot lasers and hit rocks and destroy them. And we're also going to be using this week's lesson to introduce concepts around, using our sprite objects for things like particle effects. So just before we get started, I'm going to show you what we are going to build this week. So game looks something like this. It's called Asteroids. This is a AI generated image for disclosure of our little game intro screen here. Kind of reminds me of those games from my childhood where the box art was really, really cool. And then you actually got into the game and it was, it didn't quite match up with what you saw on the box. And the AI kept making a typo in asteroids, and I decided to keep it. I thought it was funny because we're going to talk about how to use physics to have this kind of ship steering behavior, steering control. Okay. There's some instructions here. Use arrow keys to steer and space bar to shoot. So unlike the previous example we did, this one is going to use the keyboard as the control. And we're also going to talk about using canvas to create this pixelated art style. Okay? So we can click to start playing. This is what the game looks like. So with the arrow keys, I can rotate my ship. I can press up to give some gas here. And we'll talk about using sprites to create the particle effects of the fire at the bottom of the rocket. And with space, I can shoot lasers. And the problem is if I shoot the lasers, the asteroids are going to get smaller, but they also get pushed around in space. And if they hit my ship, I will lose some hit points. We can see we have a health bar here on the top left. And the goal of the game is to either destroy all the asteroids, or if you lose all your health, then you're game over. Okay? And there's a few little basic sound effects. All right, so this is the plan, and so let's dive into it. So we're going to leave this this demo aside here, and we're going to start a brand new sketch. Now, again, because we're using p5play, really quickly, we are going to import the p5play library. So we're going to go to the p5play website, grab our two scripts here, copy this text, and put this into our index page somewhere here, I guess, after the p5.js includes. Okay. We're going to save this. I'm also going to upload my my assets for this game. So we have fewer assets than the previous example. So I'm just gonna put the files right here in the root folder. So these are the assets that we have. I'll share. There'll be a link to this this zip file with the assets if you want to follow along. We have our asteroid sprite. We have our spaceship sprite, and we have our title screen just as an image, just to save time a little bit. So let's, and we have a few sound effect files that we're going to use in the second half of the lesson this week. So let's go ahead and upload these assets, and we should be ready to go. Okay. So in the first part of this week's lesson, we're going to focus on the ship. We're going to focus on building the player character and the controls. And then in the second half, we're going to add the asteroids, the game logic, the collisions, and the sounds. So because we're working with p5play, we're going to, instead of using create canvas, right, we're going to use the canvas object that p5play provides us. And I'm going to show you here in this example, we're going to use, we're going to make a square canvas. We'll say 800 by 800. And I'm going to add the parameter here called pixelated. Okay? Now, you'll see what that does in a minute. It'll be easier to show you once we actually have some objects on the screen, but a pixelated canvas in p5play just means that we can set this resolution, right? And if the actual screen resolution ends up being bigger, the canvas will scale, but our game will still be 800 by 800, and the pixels will just get bigger. Okay? So this is helpful if we want to have a little bit more control over the scale of our project. And not be too tied to different monitors, different resolutions of screens. So we know this is always going to be a square game area, and pixelated here will demonstrate once we get some assets in there. Okay? But we'll come back to that. Okay, so let's get a black background going, and we're going to start off building our ship. So we're going to create a global variable. Let's call it ship for the ship, and that's going to be represented as a sprite. So in p5play, we have sprites. These are basically our game objects, right? Sorry, new sprite, singular. These are our game objects. Once we create a sprite, it gets automatically added to this master list of sprites, and p5play automatically draws all the sprites for us. Now this ship, we're gonna represent it using an image, but before we attach an image to it, we're just going to work just using a box to begin with, so we can just focus on the controls to start with. So let's give our ship some dimension. We will say, let's give it a width of 40 and a height of 70, which happens to be the size of my image that we're going to use. There we go. That's our ship. And we are going to set also the debug mode to true. So we'll say all sprites.debug equals true. Okay, so now we can see more of a kind of a wireframe version of our ship with its center over here. So let's turn our attention to draw here, and we'll start to implement some of the controls for the ship. Okay. So let's start off with the rotation, because that part is a little bit easier. So instead of using key pressed, right, as we've done before in other P5 examples earlier in the semester, we're going to rely on p5play's own input classes. And the reason we're going to use them is that they make life a little bit easier, especially when working with the keyboard. If we want to do things like detecting if a particular key is being pressed and held down, like we're going to use for our controls here, or multiple keys being pressed at once, all of that stuff is going to be handled by the p5play input classes. And also, more importantly, we can have different respond to different input events inside different functions, which is going to be helpful when we introduce our game states in the next video. So if we want to know if a key is being pressed and being held down with the keyboard input object, we say KB. So KB is short for keyboard. We'll say if KB, if we're pressing, let's say if we're pressing the left key, okay, then we're going to say ship.rotation. We're going to rotate our ship. So we're going to add, if we go left, we're going to subtract from the rotation of the ship. Let's say 2. That's going to, the 2 here is going to be how quickly we rotate, right? And then we'll do the same for the right key. Okay, let's hit play. And now we can rotate this box. You can't see, but if you press and hold, left or right, we can now rotate the box. Okay. So eventually that's going to become our ship. All right. Now, if we wanted this box to move, we are going to use the up key. So we'll write another if statement here. We'll say if keyboard pressing up. And this one, I'm going to use the curly brackets. Now notice here, I didn't use curly brackets. If your if statement only has one line of code in it, you can skip the curly brackets. You don't have to do this necessarily. Just be careful if you do that, because it's easy if you end up adding more code later on. You can forget you didn't put your curly brackets, and only the first line will be part of the if statement. Okay, so, but in this case, this is very concise. We just have one line here for the rotation. It's okay to omit the curly brackets. For the up key, we're going to do a little bit more. So we're going to put in our brackets here, because we're going to have a couple of lines here for what happens when we go up. All right. Now, there's a few ways that we can do motion in p5play, but what we're going to do here is we're going to use the apply force method of moving our ship. Okay? If we go to the p5play documentation real quick, there's we'll see that if we click on the sprite object documentation and just kind of scroll down here, the basic movement for sprites is setting the sprite's speed or velocities directly. Okay, and that could work. You know, we could say let's see when we press the if we're pressing the up key. Oops, sorry. Let me close that. This is the completed example. If we press the up key, we could say ship.speed equals 2. And that would cause our ship to start moving. Right? Now notice it's not moving in the right direction, but we'll come back to that. The problem with using this method is that if you have other forces, that other objects that are going to run into your ship, this kind of overwrites all of the physics interaction. So instead, we're going to go and do the more advanced movement here. Advanced movement works by applying forces onto an object, so that there could be multiple forces acting together on an object at once. Okay? For example, our ship is going to be able to fly. We're going to be able to move our ship, but then if we get bumped into by an asteroid later on, that's also going to be another force that's going to affect the overall rotation and velocity of our spaceship. Okay? So we're going to use this apply force technique. And the way this works, we're going to apply an amount of force, and this is going to push our object in the direction that's represented by the bearing angle. Okay? So let's go and apply this to our ship. We'll say apply force. Okay? So let's apply force, and we're going to apply -30, because when we press up, we want to go up. So we're going to go with a negative number, and we're going to set the bearing of our ship before we apply this force. We'll say the bearing of our ship, that's the orientation of our ship. We're going to go ship.rotation and see what that looks like. Okay. So now I can go left, right, turn my ship, and if I press up, you can see that, oh, geez, we're going off screen. We can see that my object has started to move. Okay. Now there's a bit of a mismatch here between the angle of my my ship and the bearing. Okay, it seems to be off by 90 degrees. Let me run that again for you. If I press up right now, if I press up, right, this is actually pushing me to the left. So what I'm going to do is just we're just going to add 90 degrees to this bearing angle. Okay? I think that has to do with the fact that the assumption here is that the object should be facing right, but we're going to want our ship to start up just facing up. So we'll just account for that by adding 90 degrees here to our ship rotation. So that's going to become the bearing, and see what's going to happen if I do that. Now if I press up, it's actually pushing me in the direction that it looks right for my ship. So the kind of following the orientation of the rectangle. Okay? And if I release my up key, you'll see that the ship slows down a little bit. I mean, it keeps moving, but it only applies this force while I'm pressing the up key. Okay. All right, now we've flown off screen somewhere. Okay. Okay. So we're going to refine this movement behavior here in a second. But before we go any further, we're also going to add a little bit of a behavior to our ship, which is, as I go off screen here, I don't want to have to lose my ship. So we're going to handle this by just having this infinite world that we can fly into. When the ship leaves the screen on the right, we're simply going to bring it back on the left. Okay, and we'll do this in all the directions. So let's add a bit of code here that's going to wrap around the edges of the screen. Okay, so let's keep an eye on our ship's location. We'll keep an eye on the X position, and we'll say if that exceeds width, right? Width, and then we want to have a smooth transition. So we'll say width plus half the width of the ship itself. Okay. So if that's the case, we're going to take our ship and bring it back. Actually, let's use the height of the ship because it's taller than it is wider. So just in case, we're going to bring it back to make it equal to 0. Sorry, equal to 0, and actually negative ship height half divided by 2. Let's see what that looks like. Okay. So when we exceed the boundary on the right, it's going to bring us back to the left. And the reason I'm not putting 0 here, you'll see what happens if I put 0. If I go in and put 0, right, it's gonna, if we go fast, you can't tell, but it's a little bit jarring because the ship is gonna sort of appear right here and teleport. So by moving it a little bit further to the left, then it's supposed to be, it's gonna look like our ship is, it's gonna have a nice smooth entrance. And let's apply this logic here to all the other directions. So if we go less than ship.height over 2, right? So if we move to the left, we want to bring our ship back width plus ship.height over 2. Okay. And again, I'm using the height here in all directions because the object could have been rotated, right? But you know, it probably would work also. Oops, what am I doing here? It probably also would work if we use the width of the object. So why are we getting stuck here? Let's do the left side first. Or these if statements are following each other. And we're getting trapped. Oh, I said divided by 20. Oops. My bad. Sorry. Okay, so now that should be fine. Didn't mean to say divided by 20, just meant to say divided by 2. And let's continue. We're going to do the same for the y-axis. We'll say if we're less than, we're going to, if we're at the top, we want to go to the bottom. Be a bit more careful with my typing here. And similarly, if we're at the bottom, we want to go to the top. Okay. Let's give this a test. So now I should be able to wrap around this direction. I could turn around, rotate. That'll make it a little bit easier to develop the rest of our behaviors. Oh, one direction is not ship.height divided by 2. Always make sure that as you're adding features to your code, right, you always want to make sure that everything is working before you move forward with adding other features. Okay, so I think that's doing what's expected. All right. Okay, so now we have our rectangle that's eventually going to be our ship. We can use left and right to steer it, and we can press the up key to add a force to our ship. Okay? Now what we're going to do is right now, if I release the up key, this ship is just going to keep moving forever because there is no drag in the world. Drag is something that we add to a physics simulation to simulate resistance. So we are going to go ahead and tell our ship that our ship is going to have a drag value on it. Let's start with a drag value of 1. Okay? And what that means is that now we're no longer just in this space that has no resistance. There's now a resistance being applied to my ship in addition to the forces that I'm applying here when I'm pressing the up key. So if I'm moving, right, and I release the arrow key, the drag is going to cause my ship to come to a halt. Okay, so I can only move when I'm applying force, and that makes it a little bit easier to control and steer as well. Okay. So this drag here is really important. So this is applies resistance to the ship's movement. Okay. So we need this, otherwise we would just keep flying around. By contrast, in the second part, we're not going to apply drag to the asteroids because we want them to keep moving always, but the ship, we want to have a bit more control over it. So I'm using the drag feature here to do that. All right. Okay, so I think we're at the point now where we may want to attach a sprite to our ship. So let's do that. So we're going to go here and open up our bar here in our assets. I have a PNG file, that's the asteroid. We have our spaceship, this little spaceship.png. So we're going to load this as an image, and we're going to attach it to our ship. So a little bit simpler than what we did in the zombie apocalypse example where we used full-on an animation sequence here. This is going to be simply an image that we attach to our sprite. So it doesn't have to be an animation. We're going to use preload to make sure that our ship image is fully loaded and ready to go by the time we run into setup. We'll say spaceship.png. And then in setup, after we created our sprite, we're going to say ship.image equals ship image. We're going to attach an image of our spaceship here. It's going to take a second to load. Great. Okay. So this happens sometimes with the p5.js web editor, whereas you've uploaded some assets, and then you try to load them, and you get this error message, unfortunately. The asset does exist. It's there. It has to do with the way that the p5.js web editor stores assets. Normally, in my experience, if we save the sketch, which I should have done in the first place, let's call this space asteroids ship. Okay. If we save the sketch, try again, still doesn't work. What we can do is we can make a duplicate of the sketch. And then that one usually tends to work when I make a copy. Okay, so I'm not sure why. We're going to replace this to ship controls. Okay. So this seems to be an issue with the p5.js editor as of recording of this video. If that happens to you, this is my workaround. Okay. All right, so now we've attached an image onto our ship. If we turn off the debug mode here by commenting it out, now we can fly our ship and move our ship around the canvas. Starting to look pretty neat. Okay. All right, now just for fun, we're going to do in this game example, we're going to add some particle effects to our game. And by particles, I mean we're going to use sprites, not as a game element per se for their collision abilities. We're going to use them just as decoration. Okay? And so what I want to do is every time I press my up key on the keyboard when I'm moving my rocket, I would like to have some fire coming out the back here. So there's lots of different ways we could do this. I mean, we could have also created different animation sequences for our ship and have a little animated flame that we would trigger when we press the up key. Instead of doing this road, we're going to use the approach of just using the game objects themselves to simulate the fire. So we're going to create sprites to represent our fire that comes out of the ship when we activate the engines. So let's create we're going to create a variable here. We're going to call it fire, and this is going to become a group of sprites. Okay, so we'll say fire equals a new sprite group. Okay? And the idea is that as we press the up key, we're going to add sprites to this fire group, and these sprites are going to get their cues as to how they get created based on what's happening with our ship. So just to start off with, we're going to set some attributes to the fire. We'll say the fire will have let's say a small diameter of 5. Okay? And the location of the fire, every time we create a new fire particle, we're going to use the arrow setter function, a feature, okay, which allows us to set these attributes dynamically, which means every time new objects will be created, the diameter will be the same, but the position is going to get calculated on the fly. Okay? So we're going to start our fire based on where the ship is. Okay, so we'll say fire.x and y. I want you to start where the ship is. Okay? And just so we can test as we go along, we're going to go into this if statement here. And as we apply a force to the ship, we're also going to say fire.amount plus plus. Okay? So this is going to increase the amount of fire sprites that are in the game. Okay? And we can see as I'm pressing the up key, I'm leaving a trail of circles that are spawning off from where my ship is. Okay? Now all these objects currently, they're all objects in the game, so they can be collided with and so forth, but we're going to tweak that to become our fire particle effect eventually. Okay? So the first thing we might want to do is these are going to stick around forever. So I'm going to also give the fire particle, we're going to give them a lifespan. Okay? So we'll say, let's give them a random lifespan using the arrow setter. We'll say random 20 to 30 frames. Okay? So just so we don't keep them forever. So now as I'm flying around, you can see that these particles that are leaking, looks like we're leaking fuel right now, but we'll work on that. They have a lifespan, which means they're going to disappear on their own. Okay. Cool. The other thing that we could do is we're going to say the particles, the fire particles, they are going to, let's say that they're going to have their collider. We don't really care about the collisions, so we'll say just don't have any collider. All right, so now that looks like this, and we can see that they're no longer colliding with our ship, so they're just kind of creating a trail here behind us. Cool. All right. So we're only going to use them for their visual effect here. Or the other way that we could do this, we could also say fire.overlaps ship. Okay? And maybe we'll do that because then it'd be cool if those sparks overlaps. It'd be cool down the road if the sparks could kind of bounce off the asteroids and things like this. So instead of giving them no collider, we'll just tell the collider you can overlap with the ship. Okay? And that means it will not try to do collision between ship and fire particle. All right. Now, in addition to creating them, let's also give them a speed of their own so that if we're moving, they're going to get launched behind us. Okay? So let's say we'll go fire.speed. We're going to give them a speed using the arrow setter again. We'll say let's get a random speed 4 and 5. See, now they're shooting off. They're just always just shooting off, though not necessarily in the direction that our ship is going. Okay. So let's tweak that. So in addition to giving them a speed, we're also going to give them the same direction, like the opposite direction that our the same rotation as our ship. Okay. So let's rotate them. We'll say fire.rotation. And then look at the ship's rotation. We're going to add our 90-degree offset that we did down below here. And we're also going to add a little bit of randomness to this, just so that they don't all go exactly in the same direction. So maybe between -20 and 20 degrees. Okay? So that allows me to have the spread. Okay? And they're being rotated by the same amount of our ship. So now as I'm flying around, we can see these little particles are coming off kind of like behind me. Okay? Now they are spawning off from the center of our ship. If we turn back the all sprites debug to true, we're going to see this little cross here in the middle of our ship. And this is where the fire particles are coming out of. Okay? So one thing we could do to make this a bit more realistic is we're going to add what's called an offset to the center of our object, so that we're going to add an offset to the center of rotation. That's also going to make the steering behavior a little nicer too, because we're going to now rotate from down here instead of rotating from our center. Okay? So let's add to our ship. We're going to say offset.y, and we're going to put in half of the height of the ship. Okay, negative half the height of the ship. So let's go with 35. Like right now we know our ship is 70, so we'll say -35. And you'll see when I do this, it's not super obvious, but the cross that was in the middle here of the ship, we'll see it a little bit better if we turn off the image. The cross that was in the middle of the ship has moved down to the bottom here. Okay? And now when I rotate, you can see that I'm now rotating around this offset center point. And if I press up, now the fire is coming out of my bottom. Okay? So this is the effect that I was trying to go for. Let's bring our image back in, and let's turn off the debug mode. So now that looks a little cooler. The fire is no longer coming out of the center of the ship. Okay? Very neat. So now we have our fire going behind our ship. We could also, right now the colors are totally random for the fire. Okay? So we could also go and say, let's give it a color. So we'll say the color of the fire particles, we're going to randomize, and we could make a separate array and so on and so forth. We'll just go and do it all in this arrow setter. we'll say random color. We'll put an array here and just let's put 3 colors in there: orange, yellow, red. Okay. So when we create a fire particle, its color will get dynamically determined, and it's going to choose randomly between one of these 3. So now it looks a little bit more like fire. Okay. Works well. Okay, so that's going to be our fire particle effect. Now, the last thing we're going to do in this lesson to kind of complete the controls of our ship is we're going to give our ship the ability to fire off some lasers. In the game, we're going to have these asteroids floating around, and as we hit them with lasers, they're going to start to shrink, and eventually they get destroyed. So let's add lasers to our ship. Okay? So lasers, just like the fire that we created at the back of our ship, they're also going to be sprites, and they're also going to be part of their own group. So let's go on and make another object here. Let's call this lasers, and that's going to be a group. And let's add a little comment here at the top so we can start to see that these are our sprite objects. Okay? And this is our image objects. It's always a good idea to add comments to your code, keep things organized. As your code gets bigger and bigger, the better you are at staying tidy, the easier time you will have maintaining it and developing your code afterwards. So our lasers are going to be a new group. Okay? So groups are a very efficient way in p5play to kind of create categories of objects and then just add to that category by using the amount feature of the group. Or you can manually create new instances from the group. Okay, so our lasers, just like we did here, we're going to say lasers.x. We're going to use the dynamic setters. We'll say ship.x, ship.y, and then we'll say lasers.rotation is going to be equal to ship.rotation. Now, if this is sending us here, this is sending us this way. Okay, we want our lasers to go that way, so we're going to say minus 90 degrees here. And then let's say we'll give our lasers a color. For simplicity, let's make them all kind of hot pink. Give our lasers a speed. These are going to go faster than our fire particles. Let's give them a lifespan of 200 so that they don't stick around forever. And let's define also their size. So let's make them narrow. So here I'm defining them as wider than taller, and you'll see why in a second. That's all going to fit with the rotation. There's some trial and error here that can happen. So you'll see very quickly if you define an object a particular size and it's not matching what you expect it to do, just don't be afraid to experiment and add some offsets and do some trial and error. But I've already done this ahead of time. And yeah, so let's start with this, and then we'll start to talk about the rest of the stuff in a second. So how do we fire the lasers? Well, we could say let's add another keyboard event, and instead of pressing here, I'm going to kind of slow things down by using presses. Okay, so if we press space, then we'll fire off a laser. We'll say lasers.amount plus plus. The reason I'm not using pressing is that it will prevent the player from being able to just press and hold and then just fire lots of lasers. Now you have to like actually press and fire. Okay, so there's a couple things wrong here. Looks like our lasers are going in the wrong direction, and they don't seem to have much of a speed of their own either. I mean, they're pretty slow. So let's figure out why that is. Okay. It could be because when we spawn the laser, they automatically collide with our ship. So the first thing we should turn off probably is we're going to say lasers.overlaps ship. Okay. We don't want the laser to connect with ourselves. Oh, there we go. Okay. So the reason they were acting all funny is because they were colliding with the ship object and then getting separated, and that affected in turn their speed, their velocity, and direction. Okay. So important here, we don't want the lasers to create collisions with ourselves. So as we fire off our lasers, now we can see they're going fast and they're going in the same direction that my ship is pointing. and we have our particles going the opposite way when we hit plus. All right. Very cool. Now, we don't have the asteroids yet in the game, but once we do, the lasers are meant to be these bullets. They're going to be hitting the other game objects, but we don't want other game objects to hit them and take them off course. Okay? So we're going to say lasers.collider equals kinematic. So this is a laser is a good example of a kinematic object, which is going to be able to have an impact on other game objects, but not have the other game objects impact it. Okay? So we'll set its collider to kinematic, and just also to be safe, we don't want our lasers to start spinning around. That would look funny, so we're going to say lasers.rotation lock equal true. Okay. All right. So now that we have some properties of our lasers, we can move our ship around and we can fire. Okay. We're in pretty good shape. Now, just as a final refinement, we are going to fix the fact that right now our lasers are coming off of the back of the ship. Okay? And again, that's because if we turn on our debug mode here, remember we have our origin for the ship is over here, which is convenient for our fire effect, our fire particles, but this is also where the lasers are coming out of, because we're saying lasers.x equals ship.x and ship.y. So that could be fine. I mean, it's not the end of the world, but it does look a little bit funny, especially if we're spinning around and turning. So I don't like it that much. It looks a bit off, like they're kind of coming off the side. It would be nice if the lasers could come out of the tip of our ship instead. Okay? Now the problem is we can't have two offsets. We're using this one here for the rotation and for the fire. So what we could do is we could create a sprite, another game object that we're going to manipulate to use as the source, right, as the source of the laser's position when we create new lasers. So instead of using the ship, we're going to create a separate game object. Let's call it our cannon. Okay, let's call it the cannon. And this purpose of this cannon is going to be positioned at the tip of our ship. Okay? So this is a little bit more advanced, and we're going to have to use a bit of vector math to pull this off. But just to show you an interesting thing that we could do, basically using a secondary sprite that we're not really drawing for anything, we're only using it for its position. Okay? So let's make our cannon. It's going to be a new sprite, okay? And we're going to make it into a circle. So let's give it a diameter of 20, and it's not going to collide with anything, so we'll set its collider to none. Okay? All right. So if we make a sprite here, this is now our cannon, and our job is going to be to move the sprite so that it follows the tip of our ship around. If we can do that, then we'll be able to tell our lasers when they spawn, we'll be able to tell them to not use the ship's position, but instead to use the cannon as their starting position. Okay, let's say I do this right now. Here's what's going to happen. Right, if I fire, this is now where the lasers are going to come from. Okay, so let's work a little bit to make this sprite follow the tip of our ship. Okay? So in draw here, we could do this anywhere. We're going to do this down here. We'll say move the cannon to follow ship. Okay? So the first thing we're going to do is we're going to make the X location of our cannon at least follow the X location of our ship. Okay? Kind of bringing us back to where we started. So we'll say cannon.x equals ship.x. Cannon.y equals ship.y. So now we can see we can have this object follow us. Okay? Now if we fire, we haven't really fixed anything because we want this object to follow us, but not at the back, actually be at the front over here. So to do this, we're going to use something called an object called a vector. Okay? There's a P5 object that we can use called a vector. Okay? And vector is a mathematical concept. Without getting into the math too much, excuse me, we can think of vectors as arrows. Okay? They represent kind of like arrows pointing in space, and vectors will have a length and a direction that they're pointing in. Okay? So if we could define an arrow starting here and pointing the same direction as our ship and the same length as our ship, we could then use the XY coordinate of the tip of that arrow to locate where our cannon should go. Okay? So the way that we're going to do that is we're going to create a vector, an arrow object, based on the angle of our ship's rotation. Okay? So let's say we're going to call this cannon offset. Okay? So we're going to use the p5 vector object, and we'll say create a p5 vector from an angle. Now the from angle function will only take angles in radians. Okay, so our ship rotation right now is an angle in degree. Okay, so we'll say ship rotation. That's an angle in degrees. So we want to convert this angle to radians. So we'll use the radians function, and that's just the way that this function has been written. If we look at the documentation from it, from angle, if we click on this, it will warn us in radians only, and you can't use angle mode to change to degrees. So always important to read the documentation. All right. So once we have this vector, we're going to basically get a tiny little arrow that is pointing in the same direction of our ship, and then we're going to scale that arrow by setting its magnitude. We'll say the length of the arrow, we'll set the magnitude to be the same as the height of the ship. Okay, so we want this arrow to extend all the way to the tip of the ship. And then we can use the x coordinate of this arrow, the tip of that arrow, we'll say cannon offset.x, and we're going to add that to the ship position to determine the location of our cannon. Okay. All right. Now we got the angle wrong here, but that's okay, just to show you, right, what it does. So it's used our rotation, but again, because our ship sprite is kind of facing this way, it's not laid out to face horizontally. Let's do the same thing as we've done prior. So if I wanted to offset this by 90 degrees, right, we can just go and add a 90 degree minus 90 offset here to our rotation. And there we go. So now we can see that our little cannon object, we're calculating its position relative to the base of our ship using a vector, using an arrow object that we create from the ship's rotation angle. And then we scale that arrow to match the same length of our ship, and that gives us the position of our cannon at the tip here. And now if I fire lasers, you can see that they're actually coming from the cannon sprite and not from the back of our ship. So that just looks a little bit cooler. Okay. Follow the tip of the ship. Amazing. So let's turn off all sprites, debug, just so we can see our colors. Okay. So now our cannon object is a sprite in the game, right? So that's a little bit awkward. So let's make sure that this we don't see this this cannon anymore. So one thing we could do, actually, we're just gonna set its diameter to 1. Why not? There we go. So now we have just a 1 pixel at the tip here, and it's gone. We could have also set its color to something invisible, transparent, but I'll just make it tiny so we don't see it, or we see it as a single pixel, but it doesn't really bother me. Okay. All right. So now we have a ship that we can control with the keyboard, slightly more advanced movement behavior than we did in the previous game example. We've used sprites to create a particle effect for our ship, for the reactor, and we're also using sprites to create our lasers that we're now firing off using the spacebar. Okay? And again, we're using presses here, not pressing. I just also want to demonstrate if we did use pressing, here's what would happen, right? Which, you know, could be cool, but now as I'm pressing, I'm just creating a lot of lasers. That would make the game a little bit too easy, in my opinion. So presses just means that we have to repeatedly press in order to shoot. So this is just design decisions. Okay, so we'll leave it at that for the first part of the lesson this week. In the second part, we're going to add to this our asteroids, and then once we have asteroids, we'll talk about the game mechanics, the game logic. We'll add game states to turn this this little ship demo into a fully playable game. I'll see you in the next video.